8.5. Today we're taking a look at one more way to graph a quadratic function, and that way is called the intercept form. Sometimes it's referred to as factored form because when we factor a polynomial, we break it down into its linear factors. This helps us find the x-intercepts, and therefore they're interchangeable: intercept form or factored form. Let's take a look and dive in. Intercept form of a quadratic looks like this. F of x is equal to a times x minus p times x minus q, where x minus p and x minus q are the linear factors of that quadratic. These also lead us to our x-intercepts, or our zeros. Now, when it comes to graphing intercept form of a quadratic, we know that our x-intercepts are going to be the 2 points p, 0, and q, 0. And if you notice from up above here, that would take on the opposite signs of the p and the q values in the equation. The axis of symmetry can be found by taking p and q and combining them and dividing by 2. Our parabola is going to open up, remember, when a is greater than 0, and open down when a is less than 0. And a always still tells us whether it's a vertical shrink or stretch. Now, the coordinate of the vertex, the x-coordinate of the vertex, is going to be found by taking that same axis of symmetry equation. We're going to add p and q together and divide it by 2. And then we're going to use that p plus q over 2 to find the y-coordinate by evaluating f of p plus q over 2. This will lead us to that y-coordinate of our vertex. Let's see what we mean by doing a few examples here. In example 1, we want to find the axis of symmetry and the vertex for the quadratic function. Now notice it's written in vertex form already. Sorry, not vertex form. It's written in intercept form because it's factored down for us. So our p value here is 5. Our q value here is -1. Those are our x-intercepts. And we can find our axis of symmetry by adding p plus q, so 5 plus -1, and then dividing it by 2. That's 4 over 2, which is 2. So our axis of symmetry is the vertical line x equals 2. To find the vertex, we are going to evaluate our function for that x value of 2. So that means we're going to substitute 2 in for x. That means we're going to take 2 minus 5 and multiply that to 2 plus 1. Well, 2 minus 5 is -3. -3 times a +3 is going to give us -9. So this is our y-coordinate of our vertex, and therefore our vertex is 2, -9. All right, let's do example B together now. We're going to start off by finding our p value. Our p value here is 4. Our q value here is 6. And therefore our axis of symmetry is going to be the sum of p and q divided by 2. That's 10 over 2, and that's 5. So our axis of symmetry is the vertical line, x equals 5. Now to find our vertex, we're going to evaluate our function for that x value. -2 times 5 minus 4 times 5 minus 6. That's going to result in -2 times 1 times a -1, or in other words, a +2. So the vertex of this quadratic is 5, 2. All right, what happens when we start graphing now? Again, without using technology, we're going to graph the quadratic functions by finding its key properties. So you can see it's already listed here in intercept form because it's broken down to its factors. We're going to find the x-intercepts. So our x-intercepts are 1, 0. Our p value here is 1. Our q value is -3. And -3, 0. So we can plot those 2 points right away. That's where it crosses our x-intercept. Finding our axis of symmetry, and we're going to say our p plus our q, that's -3 plus 1 all over 2. That's -2 over 2, which is -1. So our axis of symmetry is this vertical line straight down, up and down through -1. And now in order to find our vertex, we're going to evaluate our function for -1. So let's substitute -1 in here, and that gives us -1 minus 1 times -1 plus 3. So We have negative 2 times a positive 2, and that results in negative 4. So our vertex for this parabola here is negative 1, negative 4. So going over negative 1 and down to negative 4, here's the vertex of my parabola. I know that my a value here is positive 1, so because a is equal to 1, and it's greater than 0, it opens up. And this also tells me that I can move to the right one and up 1 point, and to the left one up 1 point, because it's symmetric. And now I have enough points to graph my parabola. There you go. You graphed your first parabola quadratic that was given to you in intercept form. All right, so a quick little reminder. Factors of the polynomial will lead to the zeros of the polynomial. And in fact, any factor x minus n of a polynomial, n is considered a zero of the polynomial. In order to find those zeros, you took each factor and set it equal to 0 and solved. So our first 0 here, in this first one for example 3a, our first 0 is positive 5. Our second one is negative 7. Okay, and likewise for letter B, I'm going to take my factor x plus 4, set it equal to 0, and my 0 is negative 4, and x minus 12, set that equal to 0, and x is equal to positive 12. Notice that I don't take or do anything with that negative 3, that a value. That's actually not really it's not really a 0. It doesn't contribute to the 0 of the polynomial. That's what I want to say. All right, it is a factor, but it's not a 0. All right, in letter C, we're going to factor out a GCF first. This one's not given it to us in intercept form, so we got to find it. When we factor out a GCF of 2, we're left with x squared minus 4x minus 12. Now I can factor this quadratic down further, looking for factors of negative 12 that combine to be negative 4, and that's going to be a positive 2, oops, that should be a 4, a positive 2 and a negative 6. So my factors are x minus 6 and x plus 2. All right, now to find the zeros, I'm going to say that my 0 here is 6, and this other 0 is negative 2. All right, and go ahead and try letter D there on your own. Let's take a look at example 4. Example 4, we're again asked to graph the quadratic function. Actually, we're asked to factor the quadratic function so that you can graph it using the intercept form. So looking over here, I have x squared plus 3x minus 4. We learned how to graph these ones in our previous lesson, but let's see if we can factor this. I'm looking for factors of negative 4 that would combine to be positive 3. Well, that is a negative 1 and a positive 4. So I can factor this polynomial down to x minus 1 times x plus 4. Now it's in factored form. This helps give me my x-intercepts. My intercepts would be 1, 0 and negative 4, 0. So I can plot those right away. And this is going to help me find my axis of symmetry. Now let's do this one graphically. My axis of symmetry is going to be the halfway point between P and Q. So if I count up my spaces, there's 1, 2, 3, 4, 5. My axis of symmetry has to be the halfway point there. So that's the vertical line. X equals negative 1.5. All right, now to find my vertex, I need to plug that negative 1.5 in. And I'm going to use my factored form to evaluate that. So that gives me negative 1.5 minus 1 times negative 1.5 plus 4. And that's negative 2.5 times a positive 2.5. And that results in negative 6.25. So my vertex is at the point negative 1.5 comma negative 6.25. All right, so I'm going to go over 1.5 to the left, down to 6.25, which is about right here. There's the vertex of my parabola, and I'm going to sketch that parabola out as best I can with my digital pen. Okay, finally, give the domain and the range. The domain, like all quadratic functions, is going to be all reals. My range now is all reals greater than or equal to my minimum point of negative 6.25. All right, for our final example for today, we are asked to write a quadratic function in standard form that has the given characteristics. In letter A here, we see that it passes through negative 5, 0, and negative 2, 0. These are my x-intercepts. Well, if it passes through negative 5, 0, and negative 2, 0, then the factors x plus 5 and x plus 2 must be the two linear factors that give me those intercepts. So I'm just going to multiply these two back together, and I'll have my quadratic in standard form. When I do that, I'll end up with x squared plus 7x plus 10. And there is my quadratic in standard form that passes through the points negative 5, 0 and negative 2, 0. All right, our next one, we're given the vertex of negative 3, negative 2, and it passes through the point negative 4, negative 1. So I'm going to use vertex form now, which says to substitute in your h and your k and another coordinate x and y so that you can find your a value. So my h is negative 3, my k is negative 2, I have an x and a y. All right, so our first line here, we'll read like this, x plus 3 squared minus 2. We're going to substitute in our negative 1 for y, a, and then we have negative 4 for x. Now we're going to solve for a. So negative 4 plus 3 is negative 1. Negative 1 squared is positive 1. So this is negative 1 equals 1a minus 2. We're going to add the 2 over. We get an a value that's equal to positive 1. All right, so we don't really have an a value here. My equation then in vertex form is going to be x plus 3 squared minus 2. Now from here, to write this in standard form, you're going to want to expand your x plus 3 and then add in your negative 2.